So here we're going to do K equal 1/2 mv squared. We know that 1/2 mv is usually a constant, and we're going to assume a constant for now to make things easier, because there's some equations that have dt on the mass, but this one will not do. So this is what we have. This is just using chain rule. So what I did was basically take a derivative of v square. So I did a dvt, and that is basically this. And you can prove that by doing a dot product on it. dv dot v, right? dt equal v dv dt plus dv dt v, which is 2v dv dt. Okay? Anyways, that is what it turns into. Now, here's the interesting thing. That means that this gets deleted, MVA. Now, a lot of people won't know this, but this is actually, oh, I forgot the dk, sorry. This is actually the definition of power. Um, in some ways to say it. But let's say you didn't know that. The first thing I would check is it a force? And is it a force? No, because ma is a force, which is F, and then this is equal to Fv. Okay, that's not a force, so we can delete that. Is it a momentum? Is it mv? No, so delete that. Is it work? No, work is energy. So it must be power. So one way or another, there was two ways to do it. It is power nonetheless. All right? Classic way to look at it. Problem 2 and 3 refers to a following illustration of. All right, over here we have this. This is going to be the velocity at the tangential to A. So we need the height of this. So we're going to start with mgh, well, that's the potential energy, PE plus KE equal PE plus KE, right? So we need 1/2 mv squared here. We're going to actually make this the zero line. So with the 60 over here, you can actually do something called, let me check, get this distance. So 5, because it's 5, and it's going to be, you can think of you can think of two ways to do this. I'm going to choose to do it the way with 5 this way, I guess. We're going to do sine 60. And that sine 60, whatever it is going to be it, the h. So 5 sine 60, that's about equal to 5 square root of 3 divided by 2, according to the calculator. Now, with that said, we can plug that into h, and then we can get what? We can cancel these two out. We get the 2gh, square root of that. So square root of 2gh of 5 square root of 3 divided by 2. So second square root, 2 multiplied by 9.8 multiplied by, oh, h is gone. Multiplied by parentheses, this, parentheses, equals, I get C. I get 9.2125, which is about a B. Sorry, I'm a B. I get B. Sometimes I slip the words out wrong, but I get B on that one. So next is this question, number 3. So what's the instantaneous acceleration in the direction of the traveling of the disk at point H? There's no H. Let me look at the original question. It meant B. It meant B, sorry. And B is this one. So let me just change. Yeah, as you can see, there's a lot of mistakes on this one. I don't know what happened. There's just a plethora of mistakes. Yeah, I already found like a ton of them earlier, which is why I had to do it by hand. It literally got deleted, one of them. So let me do, what color is this? Just regular color. I'm gonna choose B like this. It's fine. You get the point. Actually, I still don't like how. I mean, I need to do this. I think. Yeah, point B. So now you get the SB. Yeah. Just so you know, other people are gonna use this, my friends. So that's why I'm being careful about this. All right, this one had a mistake again. So this one, I mean, you can guess by looking at the change I made, that's A, because there's no answer. This is basically messed up because I don't know, it scanned it wrong or something, I don't know. But the instantaneous velocity at point in the direction of travel. So it's asking for AT over here, and AT equals 0. There's only AC. AC is a value. AC equals some value. And I actually calculated it just because I was actually thinking maybe it's this answer and it was worded wrong, but it is this force at that point, just from fact. But no, the wording of the thing was right. It was the answer choices that were wrong, and also actually the wording was wrong too. It was B when it said it was something else. So yeah, no, it was a messed up question, but there we have it. We're done. 1 kilogram disc with a diameter of 10 centimeters and a width of 4 centimeters is placed on the edge of the top of an incline 1 meter high. The ramp is about 10 degrees. At the bottom of the ramp is a spring whose spring constant is K equal 2000. The disc rolls down the ramp and compresses the spring and comes to a complete stop. What's the maximum compression of the spring? So this over here is m volts. Well, I was going to do 1/2 m kx squared and just solve that. It says volts, which implies, does this imply that we need to go angular? It does not give me radius, so I don't think so. I think it's just a misplace of word, which I wouldn't say anything about because it does do that. It makes mistakes all the time, and so far I made a lot, so I'm assuming it's just a writing error. Okay, so we could just do this. So MGH, what are we looking for actually, first of all? We're looking for what's the maximum compression? All right, 2 MGH divided by K square root is all we need. That is X. Yeah. Am I forgetting something? I hope not. You gave me 2 multiplied by 1 multiplied by 9.8. The height was 1, and why would you give me the? I don't understand why you gave me all this extra information. I'm trying to figure out what your goal was, but I think your goal was to just confuse the hell out of me. I don't know why you would do this to me, genuinely speaking. Like you gave me a bunch of information about the angles and that, and it's completely useless. Okay, I get 0.09899 multiplied by 100 because that's cm, this is millimeters. So that's 99.8, which 98.9, which is 9.9 if you round it, so it is A. Still don't know what the point of some of the questions are. A wording of the question, there's like a bunch of extra information that I did not need, and the wording was off. But anyways, two balls with a total mass of 2 kilograms collide head first to each other. The velocity of each ball at the time of the collision is 2 meters per second. 2 meters per second. Oh my God, we're doing efficiency of restitution. I didn't think we would be doing that. Mostly because I can't imagine. I mean, I didn't imagine the FE exam to do that because it's something specifically done in the yes we learned it in class. I just didn't think we'd do that yet. It's E. Where's E? Over here. So E equal V prime 2n minus V1 prime n divided by V1 n minus V2 n. So velocity normal to the plane, impact before impact, and velocity normal to the plane after impact. So this is after. So I don't know why they don't use F and instead demand to use this prime notation. But all right, we can work with that. So this equals 0.5 apparently. Um, and this is energy. So here's a little trick of your we'll use momentum, but this is actually derive E by energy. We're not going to derive it, no need. So mv plus mv initial 1 2 1 2, this is before, equal mv, so this is going to be 1 and 2, 1v prime 2 plus mv 2. I already know the answer, by the way. I mean, actually no, never mind, I don't know the answer because the atmosphere is like that. So that is, I believe, the correct way to write it. So before I do anything, let me just simplify some things, okay? So m, we know m, right? M is 2 kilograms. So we know that this over here is 4. We know this is 4, right? There's no need for me to guess. There's two equations, two unknowns, so this is just a solution problem. So there's 2 over here, 2 over here, and this E is 0.5, and we know the beginning of it. Wait, that's 2 minus 2. That's 0. That shouldn't be what's happening. Oh shit. One of them is negative probably, and I didn't write that. Yeah, so I should probably write this down. V over here is 2 meters per second, so I don't make this mistake here. V over here is equal to negative 2 meters per second because this thing over here is doing a positive direction this way, 1d positive. So that's a negative now. So which one do I choose negative? I don't know, it doesn't matter. V2 and V1. So V2 is now negative. So what that means is 2 minus minus 2 equals 4, right? Yeah. So we get wow. This equation goes to 0, which makes sense because they're colliding to each other. Vi prime plus V2 prime. And then the second equation becomes V2 prime minus V1 prime equals 0.4 multiplied by 4. And then now we can solve this thing. So V12 minus V1 prime equal, what's 0.4? That's 1.6, right? 1.6, and then 2V1 prime plus 2V2 prime equals 0. And I told you there's a system solver in your calculator. Although I don't trust it anymore because if it made a mistake and I was spending like 30 minutes trying to figure out why it wouldn't give me the answer that I know is correct. But it turns out the problem solver in your calculator is not that great. It has some loose parts to it. Basically, it's not 100% accurate. This is 0. Oh, okay. And then 1.6. So if your answer choice A, B, C is like not distinct enough, it may cause some problems. Okay, But this time it's not that. This time is my human error. I made a mistake in one of these equations. Which one is it? It's a question. Okay. So V1 plus V2. Yeah. 2V2. 2V2. That's right. And the last one is V2 minus that 4. Let me check the original question. Yeah, I think I did it correctly. Did I multiply this wrong? Oh, 0.5, dude. Oh, there we go. There's the mistake I made. So this is a mistake I did. This is supposed to be 0.5 multiplied by 4, man. That is 2. Okay, so 2, I get x equal -1 and y equal -1, which makes sense. I mean, I expected kind of that. That's why I didn't say anything. But yeah, I expected that because if Israel was 0.5 and they're both the same velocity and same mass. So I was expecting something like half of that earlier, which I should have told you, but I shouldn't have told you. But what's the loss of energy in the collision? So the loss of energy, well, we know is 1/2 mv square, right, for one of them, plus 1/2 mv square for the second one, and then we can do plus minus parentheses 1/2 mv1 pi square plus 1/2 mv1 pi square. We know v1 pi v2 pi is 1 sequentially if we square it, and we know this is 4, so we just have to do the math here. So we have everything's divided by 1/2, so we can clear everything here. We can do 1 divided by 2 parentheses. The mass is 2 multiplied by 2 square plus 2 multiplied by 2 square, and then minus what's the mass? 2 multiplied by 1 square, so just leave it like that. 1 square minus 2. Am I correct? I get about 6 joules lost. So that's C. All right, we move on now. And let's try to delete before I move because it might confuse you when later looking at it. Because if you're skipping all around, then it might confuse you. A two ball of clay moved at what even is that? I need to look at the original question again. Because that is unreadable. Uh, what it says 40. It's supposed to say 40. Well, I guess it's kind of readable. Let's just kind of like make it like visible because that is not fit for human eye. All right, a 2 kilogram ball of clay moves at 40 meters per second, collides with a 5 ball of clay moving at 10 meters per second directly toward the first ball. What's the final velocity if both balls stick together after the collision? Okay, this is just simply not MV. That's the energy. So you have to do MV plus MV1, 2 equal M big M V final. Okay, so what you do is 2 multiplied by 40 collides with a 5, which is a minus now because as we discussed, direction matters. Don't forget the direction like me, like last time. So this is 2 plus 5, and V final is this. V final equal to 40 minus 5, 10, and then this is 7, and then this is over here. Let's just do all the math in my calculator real quick. 2 multiplied by 40 minus 5 multiplied by 10 divided by 7. Well, that is about 4.28571428, which is 4 point this thing. I'm assuming it's right. I don't know. Sometimes these videos I get things wrong 100 times and then I get it right. So sometimes I cut it, yeah, and make it, bearable because you don't want to see like it. So, Pocky Hawk travels at 30 kilometers per hour, hits a massive wall at an angle of 30 from the wall. What's its final velocity and deflection if the coefficient of restitution is 0.63? So you go over here, coefficient of restitution equals E equal mu squared 2 minus V1 n. You see this n over here? We're actually going to have to use that over here because this is actually only valid for the normal phase of it. So for example, if I'm hitting a wall and over here, wall, um, first of all, MV plus MV, 2 equal M1, sorry, V1 prime plus MV, this equation doesn't work because you're approximating one of them to be 0. Therefore, you're getting an invalid solution where you're saying MV1 equal MV2, where there's an energy loss, and so it's just invalid. And this is the world of physics. In the ideal world of math, this is not a problem. But in the world of physics, you're applying the boundary conditions and boundaries of the world. So yes, it's a problem. Excuse me. So first thing you have to do is get the normal of this, which is going to be 30, and it's going to be, it looks like its deflection at 30 is this thing because it's a massive wall at the angle of 30, so it's coming at 30. So that means the velocity is that, so it's going to be no, it's going to be sine. So 30 sine 40 is the only thing that's in play. And also V2 is 0, so delete these two. So V1 E equal minus V1 N. and that makes sense. And this is going to be in the y direction because it's a normal. So in that case, it's 30 sine 4e, e, which is 0.63, equal negative v1, which is, it doesn't matter because we're going to do absolute, but if you want to be more accurate, you can do this, and you can say v1 equal negative version of that. So in that sense, we get negative 30 multiplied by sine 4e, and then you get parentheses multiplied by 0.63, which is about 12, which is about negative 12.14, something like that. Oh wait, did I miss? No, 12 point. Yeah. Sine. No, no, that's wrong. I remember because I actually made this mistake here last time, so I know that I did something wrong because last time I got 9.45 because I'll be honest, I did this question multiple times because I didn't realize I forgot that the normal was important and did x and y like a noob. Anyways, this is why I got 9.45. Sorry, my apologies. This is supposed to be 30. That's why the problem happened. Anyway, 9.45. So this is 9.45. Anyways, and then we have 30 sine 30 cosine 30 to play. And we do 30 cosine 30 parentheses over here, which equals to about 25. So if it's 25, we know the negative version is going to be, is going to not, it's not just going to continue. There's no problem with it. 25.9. So we can say, clear all this, 25.9. Oh, wait, did I say 25.9? 30 cosine 30. Yeah. Square plus parentheses 9.45 about square equals that. So I can do 9 point this square equals something like 89. Anyways, and then I can do square root of parentheses 89. So just delete the one on the end because I have a negative on it because I didn't remove it when I squared it. Plus 25 squared equal, I got 27.64602, which we don't even have to care about the degree, but if you want to do arc, it's just arc, whatever that was, you're just gonna have to find it. I believe it's arctan. You're gonna use V1 and V2. So you're gonna use final velocity like this. If you want to do it, go ahead. And it's this is V2 that got deleted and V1. If you wanted to get arctan, it should equal 20, but I don't care because I already got the answer is C from just doing the magnitude. So just do the magnitude thing on that one should be enough. All right, the impulse moment principle is most useful for solving which of the problem? Okay, so impulse moment problem. I don't think. All right, so what is it? I think force is a good thing. You need a force. Anything needs a force. Velocity, yes. Time, yes. Velocity, acceleration, mm, and time, it never can do that. That is impossible. I don't like this question. This question's awful. But velocity, acceleration, time is there has acceleration. This acceleration is A, is obviously A, because that's the only one that doesn't have acceleration. And force, yeah, that one actually has an impulse something. So you can do an integral of dp dt to get the force. So that no, sorry. The derivative of dp dt equals force. So there is a reason for you to use this. And then you can do integral of that, getting some kind of power, not power, impulse, or what they call impulse, yeah. Whatever. Either way, that's A. The other ones don't even make sense. All right, next one. 12. Let me double check. Yeah, something. I'm just making sure it's didn't bug out. All right, a 12 kilogram aluminum box is dropped from rest into a large wooden beam. Okay, that's awesome. Okay, wooden beam. The box travels 0.2 meters before contacting the beam. Okay, 0.2. After impact, immediately bounced 0.05. Ah, one of these questions. Okay. What after impact? What is the after impact the box bounce 0.05 above the beam surface? What is the impulse does the beam impart on the box? Ah, one of these questions. Yes, impulse. No, is delta P. So you can say mv1 minus mv2. So it's 2 over 1. So you need the velocity before and after, and this is gonna be a time. So how we're gonna do this is straight up and down. So what we're gonna do is mgh equal 1/2 mv squared, and that's gonna give me v1. No, V2. That's gonna be the initial velocity that we get. And then so that means and then we're gonna do again MGH with this is gonna be 2, I guess, even though it's gonna be the first one we use, equal 1/2 MV1 squared. I should have reversed the order of it, but who cares? Anyways, we got rid of this, we get rid of this, we get rid of this, and we say velocity equals square root 2GH2, 2GH2. So we find that it is square root of 2 multiplied by 9.8 multiplied by the height originally, so that's 0.2, and that's V2. V1 equals the same thing, 2GH1, but oh, we find that the square root of 2, 9.8, and then 0.05. Oh, I hope my face didn't block things. I keep on forgetting to close the face module. Anyways, we just have to solve this one. So 2 multiplied by 9.8 multiplied by 0.2 is about 1.98. So V2 equal 1.98. And then we do the same thing with 0.5 is about 0.98. So this is the hardest part because you never expect this, but you need to actually now, because you only got the magnitude down, you need to figure out if it's negative or positive. This actually should be plus or minus, plus or minus. I just didn't do it. But now it matters because this way is positive for I decided. So V2 is positive. V1 is actually negative now. So all you have to do is basically 12 parentheses, 1.98 minus parentheses minus 0.989. So you go into your calculator, 12 parentheses 1.98 minus parentheses minus 0.989 equals about 80, no, 38, 35, 35.628. 35.628 is what I get, which is about, C. So you plug in C and you're good. A uniform rod is 1 meter long and has a mass of 10 kilograms. It is pinned at point A, a frictionless pivot. The rod is released from a region 45 degree from the horizontal. The drop of the deflection is an ideal spring. It is located at point B to contact the tip of the rod. Where the rod is horizontal, the spring is constant 98. Okay, what's the velocity of the rod tip when the rod just comes horizontal? This is actually using probably 1/2, what was it called again? I'm pretty sure it's called like omega. Yeah, I'm gonna have to do that. So here's the thing. Because of the distribution over here, there's absolutely no way for me to use the mass principle here. So the only way to get anything done in this question is actually use omega square. Now, what it is basically still energy, is rotational energy instead. So you're gonna have to put down over here U or PE equal 1/2 I omega square. So mgh equal L, no, I 1 I omega square. So the truth is there is 1/2 mv square plus 1/2 I omega square. And this is called what, if I remember correctly, the kinetic energy total. So kinetic true. So it's a kinetic, basically. And then you basically don't have any velocity in the I can't say it right. There's a translational velocity and there's a rotational, that's what I'm trying to say, but I can't say it correctly, so let's move on. So from this, we're supposed to be able to get anything we want. Well, anything theoretically. Anyways, we need to do what we call centroid. H is a centroid over here, so we can actually put the gravitational force over here. So if I were to put mgh, because a lot of times we do care about how its relationship is in the center of mass. In this case, it's the middle, otherwise known as a centroid. I've been saying it like 16 times now. So let me just do that. I'm going to shut up now. Anyways, next thing we need to do is get I. And again, we are not doing it by hand. We are just going to go over here and look for a table of it because I'm lazy. Where is it? Is it all the way at the bottom? Yeah. And we'll be using ml squared divided by 3 equals I, because that probably is the easiest. What we're looking for is the velocity at the tip. So we need to do omega, and then we have to do omega equal v divided by r, because omega r equals v. So mass is 10 multiplied by the length of it, which is 1 squared divided by 3. Well, that's it. Equals I. I'm pretty sure that's what you would have gotten to. Okay, so h then equals 1, and then it's going to be over here divided by 2, and it's going to be, because it's only looking at the uh horizontal length over here, h, it should be sine 45. Okay, we have everything. So basically now we have 2 mgh, which we're just going to substitute in right now because why not? G 1/2 sine 45. And then we're going to do divided by I square root. So this is what we have, and we grab our calculators and we just say second square root division over here on the top is 2 multiplied by whatever mass it is, 10, multiplied by 9.8, divided by 2, multiplied by sine 45, parentheses, and then the bottom is a division, whatever 10 divided by 3 is, which I have no idea what it is. I get 4.56, so to speak. It is, no, sorry, that's not right. That's not right. My apologies. That's not right. So I get omega equal 4.56. That is radians per second. And then you have to say omega equal V over R, which is 4.56 divided by 1. Now is the right answer, which is 4.56. So it is 4.6. But it's important to know the method. You got the right answer, but didn't get the right method. That's kind of iffy, in my opinion. I mean, I'm okay with it. You're fine. But I like to have the method down. This is my opinion. How far will the tip of the rod bounce after striking the spring at B? Oh, wow. This is an interesting question. Since the pivot is frictionless, and this, wait, isn't this just the same space? Yeah, it would be because, yeah, I don't see why it would be different. It would just be going back. It's frictionless. So I would have just said, this is over here. So I guess it's just trying to give you points. 1 sine 45, right? Whatever that is, which calculator 45, what is it? It is about 0.71. Uh, well, what did they want? Oh, it's centimeters. So it's just C. Um, that's there, I guess. That's the question. Assume the rod is dropped from an unknown angle. The angular velocity of the rod is 10 radians per second. Okay, the angle is not known. When the rod hits the spring, what would be the maximum deflection? Oh, okay, that's easy. 1/2, what is it? Drop at unknown angle, but there's no potential energy interference, right? It's just pure when it hits the spring. Okay, so it's I omega squared equal 1/2 kx squared. So that's what happens. What's the maximum deflection? We get rid of the 2. So we get I over k because 1/2 I omega squared equal 1/2 kx squared. So get rid of that. I already said that. Square root of omega squared equal x is what I'm doing. I don't remember what I was. I was something like 10 over 3, right? 10 over 3. Let me just check. My calculator probably, you know what? I'm going to assume it's 10 over 3 because that's what I remember. 10 over 3 and then divided by what? K is what? 98, which then is multiplied by 10 square and then it's square rooted. I get 1.8442, so I'm going to assume is B and move on because that was good. I think that was a good answer. All right, next question. A pickup truck is traveling forwards at A pickup truck is traveling forward at 25 miles per second. The bed is loaded with boxes with coefficient of friction of 0.4. What is the shortest time that the truck can be brought to a stop such that the boxes do not slide? So we need to do what we call friction force. Well, interesting. So this is definitely an impulse question. And we know what the friction force is. It's equal to mu mg, right? So we know the friction force, we know, but what we're looking for is basically the delta time we can keep. So with the impulse, right, there's a delta P, and you might be asking, what is the shortest time the truck can be brought to stop such a box do not slide? Well, we look at the force, right? And we see a friction force, delta T equal mv delta V. So if for some reason um, the delta T is longer than the impulse, then we create basically what I'm saying is V1 V2 minus V1, where V2 must equal 0 is what I'm saying. And whatever that impulse is, we're good because it's driving forward at 25. Get it? Maybe just showing you will make it understand more generally because it doesn't make sense until you look at it. F friction, well, we can just do a division here and do a delta T over here and do M V2 minus V1 and let's shorten that by FF. Now, if V2 equals 0, because V2 should be 0, V1 is the constant velocity of the truck. So we do M divided by mu mg V1. We cancel these two out. So V1 is 25 and mu is 0.4 and then 9.8. Grab your calculators and get this answer divided by 25. And then this is actually a pretty hard question because it's all impulse based. Any question with impulse is not, it's not done much, so it is definitely gonna be hard for most, from what I experience from people. So 6.4 is what we have. Unlike the other parts of it, that's what I from what I've seen. Anyways, we're gonna do 1500 car traveling at 100 kilometers per hour is towed at 250 kilograms. The trailer. The coefficient between the tire and road is 0.8. What's the energy dissipated by the brake if the car and the trailer are braked to a complete stop? So what that really means is basically you have a mv squared, right? And now we need to do work. And if I remember correctly, work is well. Actually, that's the way I would usually solve it. Um, but no, that's how I would solve it. So this is work. Traditionally speaking, if there's something else, you would call it mu, m, g, and d. But in this case, we don't have to do any of that because it's just asking for dissipation, which means this is all going to 0. So it's turning into heat or whatever. It's not turning into gas power. And then also this one, make sure to multiply your kilometers in by 1,000 divided by 360, 600. Actually, I think you could keep the one. You cannot do the 1,000 because well, maybe you have to. But you should get in the end something that and make sure to square this off. Okay, I get something at least. I think I did not. Oh, I did not change. Okay, so here, 100 multiplied divided by 1,000 divided by 600, and then you get this. Okay, I think I got the same number like 200 times. Anyways, that 1 divided by 2. What is this? K. And then what is this? M mass. What is mass? 1500 multiplied by this squared. And this one is like 578,703 joules, but it's kilograms. So divide that by 1,000, which is 579. It's actually 578.703, but that little bit does not matter. So over here, what's the horizontal force on the trailer hitch when the car accelerates from 60 to 100 at a rate of 2.5? Um, what it's asking for? What's the horizontal force on the on the hitchhiker when the car slides? Well, isn't it just 2.5 multiplied by the weight, which is 1500? No, where's the weight? What's the weight? Hitchhiker 250. So 2.5 multiplied by, I'm glad it's not asking for the direction. That would be a little bit harder. Multiplied by 250 equals to 625. So that is B. Okay. All right, that's B. All right, 14. Now, this is a 60,000 rail car moves at 1 meter per kilometer in instantaneous coupling with a stationary of 70,000 kilograms. What's the speed of the coupled car? Oh, really interesting. Moves to instantaneously coupled to well, let me check the wording of this original piece. This is 14 question because I don't really believe it. Oh my God, the wording in here is awful. So the reason I say it's awful is because it doesn't explain what's going on. A 60,000 kilogram rail car moves at 1 kilogram per hour is instantly coupled to a stationary 70. So it is a MV plus MV equal MV final. It doesn't really, I don't really like that a little bit because I actually, it's fine. It's just that it's a little bit, the word play is a little bit, like, there, like it's fine. This is zero because of how because it's stationary. And then you just have to make this equal to the combined mass by BF. So this is like that. So it is VF equals 60,000 divided by M. M is 60,000 plus 7,000, so it's 100,000. So I have 60 divided by 100 with your name on it. So I get 0.6 km per hour. That's why I kept it in kilometers per hour because the answer is in that form. That's why I didn't do any of that to change nonce. Oh, that's why it's a two-part question. I was wondering what they're doing. All right, the 60,000 kilogram rail car moved at 1 kilometer per hour is coupled to a second stationary car. If the velocity is of the two car after 0.2, if the original direction in the original direction of the motion, and the coupling is completed in 0.5 seconds, what is the average impulse in the? Okay, so interesting. Huh? That's not what I expected. It's interesting. The I think this is just a interesting question, I guess. 0.0 meters per second and 1 kilometer per hour equals, I don't know, is 1,000 multiplied by 3600, which is about 0.27727. Okay, it's a bar on the top. Anyways, we're gonna do F delta T equal was it MV? M delta V. This is an important equation. It's going to come up a lot when there's something like this. It's looking for the impulsive force. So if the velocity of the two, and basically you're looking for F, which is basically M delta V delta T, and that is basically a derivative to be fair. But what we're going to have to do, hey, we got everything. We got 0.277. We got 0.2 minus each other, divided by 5 seconds, right? 0.5 seconds equal the force, basically. Now I can do a division, 0.2777 minus 0.2 divided by 0.5 equals 0. Uh, that doesn't seem right. I think I forgot the 60,000 on top, so multiply by 60,000. Um, because of the mass, yeah. but I'm thinking this might be wrong. Anyways, I get 9332. I'm gonna choose D and move on. I think I have chose the direction is wrong because I don't think that's right, but we will adapt. We'll say it's fine. It's like D. Anyways, it's fine. All right. What's the speed of the car when it hits the wall? 35 to 100 kilogram was traveling at 65. Oh, so this one you have to multiply. So this is equivalent to saying 65 multiplied by this is 1000 divided by 3600. And then that is 18 meters per second. And hits the wall 3 seconds later. The coefficient of friction between the tire and the road is 0.6. Okay. I don't know why you're telling me this. What's the speed of the car when it hits the wall? Oh, I see what you're trying to do. So it turns from V1 is into V0, basically. And the coefficient of friction is 0.6. So I'm assuming that is, yeah, because the drive is a friction force. So what it's trying to say is friction equal delta T equal M delta V. Anyways, so what are we looking for the speed? So V, because it's a 2 minus V1 divided by M, F friction, because that is how we move shit in it. I'm assuming that's what they're trying to say. And then it's parentheses T2 minus T1. And here's the thing, T1 will be 0 over here, T1 will be 0 over here, and then you'll say F is 3500 multiplied by 9.8 multiplied by mu. So let me just do that on my hand calculator. 3500 multiplied by 9.8 multiplied by 0.6 equals about that number in my calculator. And then you'll multiply by 3 seconds divided by 3500. I uh maybe I did something wrong here again. Um, because I get some insane number. Divided by, why do I get an insane number? Oh, because I used, no, what am I getting? Oh, shucks. I'm wrong. So this is wrong. My apologies. So it's V2 minus, this thing is not no. Oh, I see. So you keep that eraser, please. You actually want V1 in, and VF parentheses T2 parentheses M minus V2 is what you should have done. And because of that, you get 17 minus V2, which is 18. Ooh, okay. I'm gonna assume it's 0.4 because I get like 0.36. I guess it's a rounding error. So 0.4. I definitely did some rounding errors on it, so I'm just gonna assume that is why I didn't get the. Anyway, assuming that the speed of the car when it hits it absorb 0.2 meter per second. What's the energy must the bumper absorb in order to prevent the damage on the car? This is just doing 1/2 mv squared. So this is 1/2 3500 multiplied by 0.2 square. So this is 1 divided by 2 multiplied 3500 multiplied by 0.2 square, which is about 70 joules. And with that, we're done with the energy section. So last one, I believe. A. Yep. And the next section will be on solid mechanics, so that'll be interesting.